everybody that has managed to join us at this lunchtime. I hope the call of the weekend is not going to make you all hop off too quickly. I'm Liz Stockley. I'm the Chief Executive of the BDA. Delighted to be hosting another of our BDA Conversations series. Today's conversation is about gluten beyond the gut. I'll just ask Hayley to pop up a quick poll, if you would please, Hayley. And while she does that, I will talk to you about the conversations that we've had so far. We try and include emerging topics for dietitians, and so far we've had some fairly broad-ranging conversations about the gut-brain axis, women's health and the microbiome, non-food approaches to IBS. And today we're going to look at another cutting-edge topic, neurological gluten sensitivity. So if you could just complete that poll, that would be fabulous. And this just gives us an idea of what you are currently aware of in the space. For those of you that join us regularly for the BDA conversations, there will not be a poll at the end this time, but we're always delighted to receive your feedback. Thank you, Hayley. So a huge thank you today to BDA corporate member Dr. Shah for supporting this event. And I'd also like to say thank you to our guest speakers, Ian and Nick, who I'm going to introduce each of them individually just before they present to you. So our first presenter today is Ian Kroll. Ian obtained his cognitive neuroscience PhD at Newcastle University in 2015. During these studies and in his first postdoctoral position at Cambridge University, he utilised MRI scanning to investigate how different types of neurodegenerative conditions affect the brain and cognitive function. Ian joined Sheffield University in 2017 and has since worked within the Sheffield Institute of Gluten-Related Disorders. Ian continues to use brain MRI scanning and cognitive methods to better understand and characterise the forms of neurodysfunction that can occur across the spectrum of gluten-related disorders. Ian's authored a number of publications which focus on validating brain involvement in celiac disease and proving treatment effects of the gluten-free diet with respect to neurological progression. Since last year, Ian has been developing a large retrospective scale study of over 900 patients with gluten ataxia, gluten encephalopathy. I knew I was going to trip on this one. Encephalopathy. He is also currently finalising analyses for a different project examining if the presence of gluten antibodies in otherwise healthy people may be a risk factor for late life cognitive decline. So welcome, Ian. We'll hand straight over to you.
Thanks very much. And I assume everyone can see my screen and hear me okay. Yeah, thanks very much for the introduction, for having me, and for everyone who's come to listen. I'm going to be giving just quite a general talk about this topic, you know, in broadly speaking, and also kind of veer it towards diet and treatment as well, and kind of where the research is heading in that direction. So I think the obvious thing for many people, you know, when you bring this up, is to ask, understandably, well, is the brain involved in celiac disease? And I think it's worth taking a moment here as well, just to define what we mean when we say words like neurological problems. We know that celiac disease patients at quite a high rate will say that they get brain fog or words to that effect when they're in the middle of a gluten reaction, which is very interesting and very relevant to this topic, but it's also not what I'm going to be talking about today. You know, brain fog is quite a transient sort of thing. It comes and it goes. It's to do with the immediate reaction. The things I'm going to be talking about today are unfortunately, more sort of fundamental structural, essentially damage that can happen to the brain, and how that can affect patients and how prevalent it is and how severe it is as well. So when I joined the University of Sheffield back in 2017, this slide was the source of the sum total of decent research studies which have been done on this topic up to that point. So it's a bit of a mix of things here. There were some papers which focused on patients with celiac disease who went on to require neurological care, so obviously with quite severe problems. And we found in those patients that they had things like balance disturbances and sort of sensory issues as well, with some things that you could find on brain scanning to kind of support that these were happening. Then other pieces of research, from around the world have shown that people with celiac disease, there is an increased risk of vascular type dementia later in life, and supporting that, another study showed perhaps reduced blood flow to the brain. Some other imaging studies have shown changes to the white matter of the brain, which is kind of like the wiring, and I'll talk a bit more about that later. And there have been a couple of studies also looking at cognitive performance in patients with celiac disease, and have found this sometimes to be impaired as well. Conversely, this is, it's right to acknowledge that this has been a controversial area of research, and other studies have kind of come out which cast doubt on this and which say, well, is it kind of coincidental? Is it actually to do with celiac disease? Do these things exist at all? And I think the best way to sort of summarize this was there was this review paper which came out in 2019, which looked across all the different articles which have been published where doctors have looked at their groups of patients with celiac disease and have just looked to see at what rate those patients have neurological issues. So with respect to what's called here neuropathy, which are these kind of sensory problems I was talking about, the rate of neuropathy in celiac disease is apparently from 0% to 39%. And when this next point we talk about ataxia is quite a broad term, but it's really about these movement issues that patients can have as well. Again, the rate of prevalence starts at 0%, although it's also obviously reported higher than that. So these 0% figures, these are publications going, well, no, it doesn't exist in our cohort. It's not there. And I think my response to this, I think what's very important to get across here, in order to actually have a diagnosis of something like neuropathy or ataxia, your problems have to be really quite severe and serious. You're seeing a neurologist and you're being cared for in the neurology clinic because your walking ability is really affected and you might be looking at going into a wheelchair at some point. So when we get these publications saying, 0% in our cohort, what that's essentially saying is in our group of celiac disease patients, there are none who are severe enough to be all the way over there. But that doesn't mean that there's not a whole spectrum between total healthy brain and actually suffering with how well you can walk day to day, which is very important to consider and which is really relevant for patients too. I think this was summarized nicely in this review where it was kind of explaining that these kind of ongoing controversies and the variation in reported prevalence is contributing to diagnostic delays. And when we're talking about the brain, when we're talking about things which are going on with the brain, sadly that doesn't recover as well as the gut, so it's important that we do things in a timely fashion. So to put it another way, there's kind of two sides to the argument. On the one hand, the people who find sort of 0% are going, well, these other studies which are reporting issues, they probably have some sort of bias. They're being run out of a specialist centre. Their patients not representative of general celiac disease patients. And on the other hand, the argument the other way goes, well, we can lack experimental sensitivity. We can look at the wrong things. It shouldn't be all or nothing that, you might be ending up in a wheelchair at some point or not. It's important to consider the in-between range. So a few years ago, we thought, what's the cleanest way to address this problem and sort of validate the issue as much as we can once and for all. And we thought to do this, we would use the UK Biobank data, which is this giant health resource run by the University of Oxford, where they recruited 500,000 adults from the UK back in 2009, 2008, and kind of collected all sorts of eclectic healthcare data. And more recently, they've done brain MRI scanning and cognitive testing on these people as well. So at the time when we did this study, we looked in that data, the patients who coincidentally have celiac disease, who are otherwise completely healthy and who had this brain imaging data available, and there was just over 100 such people. We matched them to controls on a number of different criteria, from this database as well, so that they're very well matched. The idea being that if we compare the two groups together, this is data which is truly population data in its truest sense. It's not been collected by a research group with specialist interests in celiac disease. And if any patients with celiac disease are going to be representative of the general population, it will be the sort who show up in population data like this. So we just wanted to compare the patients with celiac disease to controls and to see if there's any difference in some areas of cognitive performance, in their quality of life. And we also did some brain imaging analyses which focused on this kind of fancy MRI scanning thing you can do called diffusion tensor imaging. Gives you pictures like this, but what it's basically really good at is giving you numbers that tell you how healthy the brain's white matter is, which, as I said, is kind of this wiring that runs through the middle of our brain, and it literally looks like that, when you image it like this. And sure enough, we did find that reaction time was significantly slower in the patients with celiac disease. So that this is seen, cognitively speaking, as a deficit in processing speed. And they were more likely to give answers to these questions about their quality of life that indicated issues with mood, with anxiety and depression, and perhaps not quite so surprisingly, they weren't as happy with their own health as the control subjects were. Now, in terms of the brain imaging analysis, so actually now looking at the health and structure of the brain, we did also find on these DTI scans significant changes in these areas of the white matter tracts, which are highlighted in these kind of example images by red and yellow blobs. So anywhere with a red and yellow blob instead of a nice clean green line, it is a part of the brain's wiring, which is showing evidence of damage essentially in these patients with celiac disease when compared to their matched controls. So I mean, it's up to other people to judge as well, but I've always felt like this is hopefully a nice, clean study, really trying to validate once and for all that these issues are there in patients with celiac disease. We can see that looking at physical details on scans, and we can also see that it does affect their well-being in the day-to-day life, how well they can think through problems, and how well they feel in a day-to-day sense too. So hopefully, is the brain involved in celiac disease? Yes. Maybe not always to these really extreme sort of endpoints that people can sometimes get fixated on, but still in a way which matters to patients. And I think that's really important to bear in mind. So going forward for the rest of this talk, I want to move out from just talking about celiac disease specifically. The way that I like to think about this topic is that there is really just one underlying phenomenon of gluten sensitivity. And when people eat gluten and they have an immune reaction against that gluten, and that immune reaction can go on to cause issues with different systems in the body. Of course, we know that gluten sensitivity can affect the gut. That's what it's most known for. What I'm also going to try and bring and show here is how much it can affect the brain too. And not to leave it out, of course, we know it can affect the skin as well with cases of dermatitis herpetiformis. But rather than it just being a clean sort of expression, that it always just goes entirely in one direction, really it's this whole kind of spectrum, and it can predominantly involve one system and involve another one a little bit, and vice versa. What we call celiac disease is simply when we have this well-defined case of enteropathy in the gut. It doesn't mean that patients with celiac disease don't also suffer from brain issues. It doesn't also mean, as I'm about to get into, that we can't have patients with gluten-related brain issues who don't necessarily have gut problems too. So I'm now going to talk about a couple of these conditions. We have a very specialist medical clinic in Sheffield, which is dedicated to reviewing patients of this type. So these are patients who have diagnosed quite severe neurological issues due to their gluten sensitivity. They often have celiac disease. Maybe it's about a rate of a third from what I've seen, but it's not required as part of a diagnosis either. So there's kind of two terms which get thrown around quite a lot. And the one on the left is the main one. So I'm going to introduce both, but then I'm really going to kind of veer over and mainly talk about gluten ataxia. Ataxia is quite a broad term. There's many different forms of ataxia, but it always means that the part of the brain called the cerebellum has undergone a lot of atrophy and has shrunk, and it has kind of run into lots of issues. So this part circled in red is far smaller than it should be. And when this happens, this is the part of the brain responsible for a number of things, but very much for coordinating movement and processing sensory information too. We can also see cases of what you might call encephalopathy, which is where the cerebrum, the higher part of the brain, can be affected as well. And this is often seen on brain scanning by the presence of these things we call white matter lesions. All these white blobs circled in red essentially shouldn't be there and are signs of damage. And the symptoms that we see kind of follow on from what you'd expect. So the more the cerebellum's involved in ataxia, it's movement, coordination, and sensation. And then we can also get more involvement of lots of bad headaches and cognitive problems too. And when I say foggy brain here, I mean kind of like a permanent foggy brain, not something that's just there as an acute response to having eaten gluten. Out of interest, I looked back through the literature just to try and find, historically, the very first time there was any hint of this with respect to celiac disease. So I found this one article by Cook and Smith in the 60s, but they themselves were referring even further back to papers from the early 1900s. And there were these two, one from 1908 and one from 1925, which talks about seeing patients with what they called sprue back then, which is what we would call celiac disease now, whose illnesses were also associated with sensory problems and with ataxia too. So it's interesting that there've been hints of this, for over 100 years now. And quite a lot of progress has been made. I think a lot of people aren't aware that it's now in the NICE guidelines that celiac disease is recognized to be associated with issues of neuropathy, our sensory problems, and with ataxia as well. And if patients show up with otherwise unexplained neuropathy or ataxia, it's officially recommended that they should undergo testing for celiac disease, which is really nice movement in this topic, but it's still just kind of one side of this coin, because it's still framing everything with respect to celiac disease being the be all and end all of the gluten sensitivity. It's obviously still not considering that these things might exist, still having something to do with gluten, but not necessarily having to have celiac disease specifically alongside that. So what's shared between these conditions, between gluten ataxia and celiac disease? And, what can we tell? I think this is one of the more promising areas of research at the moment. What can we tell from people's antibody profiles to kind of offer clues about who's more at risk and less at risk of developing these sorts of things? So, as I'm sure many people here are aware, in celiac disease, there's pretty much a one-to-one relationship between if somebody tests positive while on a gluten challenge for tissue transglutaminase or endomysial antibodies. If they test positive for one of those, they'll probably be testing positive for the other, and that means that they have celiac disease. If they don't test positive, it means they don't have celiac disease. And I know that there are some edge cases, but it's as far as medical testing goes, it's a pretty clean and reliable blood test that we can do for celiac disease here. Gluten ataxia is not nearly so straightforward. It's a bit more of a kind of a holistic clinical diagnosis. If we find that these patients have tissue transglutaminase or endomysial, that's only going to confirm that they have comorbid celiac disease. In Sheffield, we always look to see if they have gliadin antibodies, and they kind of must do, essentially, as part of that diagnosis. And their response to treatment is also part of what's taken into account. More recently, though, what I think is very interesting are these relatively new antibodies that we found in collaboration with the University of Cardiff called TG6 antibodies. So TG6 antibodies aren't as clear-cut with respect to gluten ataxia as TG2 are with respect to celiac disease, but we do see that they're very overrepresented in cases of gluten ataxia. It's kind of 3/4 of gluten ataxia cases will test positive for TG6, and it's about 1/3 in celiac disease, and it's far less than that still in a healthy control population. So it becomes even if it's not the whole picture, it becomes a very interesting question. Is this a good indicator of patients who are more likely to head down the gluten ataxia route? And if that is the case, then are those people who have celiac disease with TG6 more at risk of these things than those who aren't? And this was something we asked in a study which we published, I think, about 5 years ago now. So in this piece of research, we consecutively recruited 100 patients who just received their celiac disease diagnosis from the gastroenterology department. And none of these patients had any history of neurological problems. That was an important kind of point. You know, these are very clean patients in that respect of what you would just call typical celiac disease at their earliest point of diagnosis. And all of these subjects underwent a neurological examination. We tested them for TG6, and we also did some structural, you know, typical black and white brain MRI scans too. So in terms of the symptoms that we found, things in red on the left are on a neurological examination, and things in blue on the right are things that were self-reported. We found that there were quite a lot of, you know, indications of things that might be going on neurologically. Interestingly, about a quarter to 30% were either found on examination or self-reported things to do with sort of walking and balance, which is this ataxia sort of profile, as is around the 1 in 10 who were found or self-reported sensory issues as well. And there were a lot of headaches too. What was a good summary statistic from this was, even if you excluded frequent headaches, which I'm sure many of us have more of those than we want to, we were still left saying that half of the group had at least one feature that potentially showed neurological dysfunction. And then we did what I would call brain volumetry, which is just a fancy way of saying we take their MRI scans and we measure the size of things, you know, on those scans to say, you know, how juicy something is. You know, is it big or is it small? Is it shrunk? Is it showing signs of atrophy? These sorts of questions. And we looked at specifically what I would call the subcortical grey matter, which includes a number of different structures. And we also looked at the cerebellum, which is this big bit on the bottom that's affected in gluten ataxia cases to a really big degree. And we just looked to see if those patients with TG6 showed signs of atrophy in these locations compared to those without TG6. And 40% of them had the TG6 antibodies, and sure enough, those who did had a significantly reduced volume in their cerebellar grey matter and also in their subcortical grey matter. When we looked more closely at the subcortical grey matter areas, it was the part of the brain called the thalamus that was really driving that finding. So I think this has been a really interesting piece of research that, first of all, again, sort of makes the point that when you look in the right sort of sensitive ways, you do detect neurological issues in celiac disease patients at a higher rate than you might perhaps expect. And we also found that those with TG6 did appear to be at an increased risk of developing more of a gluten ataxia sort of profile with this sort of pattern of degeneration in the brain. And perhaps a bit alarmingly, you know, this brain atrophy, which is a fairly marked change to be able to see that something has shrunk on a brain MRI scan, that's already detectable at the earliest point of their diagnosis for these patients. These are all adult patients, I should say. None of this is childhood celiac disease, but this is already pronounced, you know, from day one. So I think that's really important to take into account when we think about their ongoing care. So the question I think all this eventually comes back down to is, does the diet help? And I'm going to talk now about a couple pieces of research just quickly, which we tried to ask this question with. So one of the things which we do clinically at the university and at Sheffield teaching hospitals is we do a kind of MRI scanning on these patients with full-blown gluten ataxia called MR spectroscopy. This is something I know Nick's going to talk about briefly as well. Just to introduce it very quickly, in MR spectroscopy, we don't really get a picture of the brain. What we do using the MRI scanner is focus on kind of like a cube of brain tissue that's maybe about sort of 2 or 3 millimeters in every direction, and maybe a bit bigger than that. And from that cube, we can measure the concentration of different brain chemicals that are located there. We get this kind of spectra with these peaks on it. Depending on where the peak is along the x-axis, we can kind of measure how high that peak is, and the height of the peak then corresponds to the concentration of that chemical. And we like at Sheffield to use this as kind of routine clinical brain scanning to track something called N-acetyl aspartate, which I've written here as NAA. And this is a marker of neuronal health, and basically more of it is better. You know, you always kind of want more NAA. And when NAA decreases, it's a sign that something maybe isn't quite as it should be. So we took over 100 consecutive patients with full-blown gluten ataxia from the neurology clinic, and we looked kind of at a baseline spectroscopy scan and at a follow-up spectroscopy scan with an average of 22 months between the scans. And we looked to see how NAA changed in that time with respect to their dietary success. Now, this is more your area than mine, I think. What does dietary success and adherence mean? I think this is a really interesting topic of conversation. For the purposes of this study, a successful diet was considered to be when at the follow-up scan, no gluten-related antibodies were detectable in their blood anymore. A partially successful one was determined to be when a patient was trying, their best at the gluten-free diet, but for whatever reason, when we do the blood tests at follow-up, there are still some gluten-related antibodies there. And then there's some patients who don't attempt the diet at all, and they kind of form the third group here. And what we found were some really neat and tidy results. So we were both looking here on the left at cases of pure gluten ataxia, and on the right of those patients who also have celiac disease at the same time. And in both cases, we see this very clear-cut pattern where those who have successfully followed a diet, we see kind of NAA starting out lower and a recovery in it after the intervention. Those who don't follow the diet at all see a decline over the time, and those who are having the partial dietary success kind of hover in the middle, maybe with a slightly slower decline, but it's fairly kind of flat line there. So I think this shows very nicely that dietary success, at least with respect to immunological results, corresponds to this sort of physical measure of brain health in these patients with gluten ataxia. The other study I'm going to really quickly talk about on this topic is one we published about a year ago, where we did a follow-up series of investigations on the patients I've already discussed, the ones who came from the 100 consecutive patients with celiac disease recruited at their earliest point of diagnosis from a gastroenterology clinic. So we invited 30 of them to come back in what was a mean of 7 years after that original data collection. And they underwent the same tests again. They re-underwent neurological examination, blood testing, and structural brain scanning as well. And we were just wanting to see how things had changed in the meantime for them. So the main focus of this analysis was to look at sort of brain development over the meantime, or rather brain undevelopment, if there was any degeneration. So because in the baseline examination we'd kind of seen evidence of atrophy in the thalamus and the cerebellum, if you remember, we just kind of reinvestigated those areas again. So we, using the exact same methods, we once again kind of quantified how big those areas were, and then we sort of subtracted the volume, one from the other, and divided that by the actual number of years between the two scans, so we could calculate a yearly percentage loss of brain volume for the thalamus and for the cerebellum. So as it happened, exactly half of the cohort had achieved negativity of all gluten-related antibodies at follow-up. Obviously, what would be really interesting here is to look at antibodies in isolation to work out which ones are more relevant than others. But when, unfortunately, we only had kind of 30 patients to work with in this study, that wasn't really possible. So we had to take this all or nothing approach, but it's something we're very interested in for future research. Seeing how symptoms changed over time is a real mixed bag. So basically anything here with the green line appears to have got better, anything with the red line appears to have got worse, i.e. become more prevalent, anything with a black line has stayed the same. So some things seem to be slightly better, some things seem to have got a bit worse. It's a bit all over the place. And again, I think with a small sample size, it's difficult to kind of tell these numbers really reliably. With respect to symptoms, there were some sort of comments which were able to be made where, for example, all of the new patients who developed ataxia in the meantime, they all were still positive for gluten-related antibodies at follow-up. But again, I think this is something where we need more subjects to actually be able to do these analyses properly. But what was interesting with the brain imaging studies, nothing was found in the thalamus, but interestingly, and perhaps as you would hypothesize, in those patients who were still positive for gluten-related antibodies 7 years down the line, they had suffered a significantly higher rate of atrophy of the cerebellum compared to those patients who had managed to become immunologically negative in the meantime, or at least by that follow-up scan. So I think this is a very, hopefully quite convincing and very neat and tidy result. This is a very objective measurement of brain health. It's computers that do the actual measurements of volume. There's no kind of bias in me sat there sort of drawing a bigger or a smaller region of interest. And what we're seeing here is a clear treatment effect of the gluten-free diet. And again, these are not the gluten ataxia patients. These are the patients who've been diagnosed with typical celiac disease as well that we're managing to see this treatment effect with respect to brain health. So just to sort of summarize everything together, we're getting to this point now where we are able to use objective measures from MRI scanning to show that really strict dietary adherence does slow progression of atrophy of some brain areas in celiac disease patients, and also restores markers of neuronal health, which we've shown in gluten ataxia patients. This is a big ongoing area of research for us. It's maybe something to talk about in the Q&A, but we have a large study going on at the moment, which is really going to look into this in much more detail. A point for discussion, I think it opens up an interesting debate about what we're trying to achieve with the gluten-free diet. You know, is it enough if these sorts of results keep coming out and keep being validated to, you know, for a patient with celiac disease to be on a strict enough diet that they're not suffering gastro symptoms anymore, but if their antibody profile is still coming back positive, you know, the brain might require the latter to be negative, but, you know, food for thought sort of thing. And the last bit of food for thought as well, which points I always think are interesting, is really what is the overlap between these two groups? How many patients with celiac disease might progress to a gluten ataxia sort of presentation if it were not for the fact that they have a timely celiac disease diagnosis and get the advice to go on the diet much sooner? We actually see that gluten ataxia is diagnosed about 10 years later than adult celiac disease patients are. So, you know, to what extent with those patients with much more severe problems are we just seeing, you know, the outcome of those extra 10 years with a completely uncontrolled diet? I don't necessarily think that that's the entire answer to the question, that it's all that, but, you know, it's interesting to think how much this might be folded into these concepts that we're seeing. So that's me done. Thank you everyone very much for listening, and you know, to my various collaborators who absolutely, you know, this research couldn't be done without them. And I don't know if we're going to Nick now or Q&A later, but I'm hanging around and looking forward to the rest of the talks.
Thank you so much, Ian. We are going to move on to Nick now. Do pop your questions for Ian into the chat, and for Nick as he goes along. Nick's presentation is about 10 minutes, so we will have time for questions and discussion afterwards. So I'd like to introduce you to Nick Trott. Nick obtained an honours degree in nutrition and dietetics from Cardiff Met. Since postgraduate training, Nick has worked in a variety of clinical areas with the NHS, including critical care, oncology and haematology. Currently, Nick's working as a gastroenterology dietitian, covering the specialist celiac clinic at the Royal Hallamshire in Sheffield. His areas of particular clinical interest include celiac disease, gluten ataxia, non-celiac wheat sensitivity, and the low FODMAP approach to disorders of gut-brain interaction. Nick is a member of Celiac UK's Health Advisory Board and was presented with the Complete Nutrition Celiac Professional of the Year Award in 2016. Nick attained a master's degree in 2017 in clinical research from the University of Sheffield, and is currently pursuing a PhD on the role of the dietitian in the management of celiac disease. So thank you, Nick. We look forward to your presentation.
Thanks so much, Liz. Can I just make sure that I'm coming through? People can hear me and see my slides. Is that coming through everyone's at your end?
Yes, yeah. I can certainly see them, Nick.
Wonderful. Thank you so much. Well, it's so great to be here with you all on a Friday and to have listened to Ian's really fascinating talk. Whenever Ian does talks, I always learn so much. So it's good for me to be here as well. But I want to focus on some of the some aspects of diagnosis as well, but also looking at the sort of the dietary and the clinical side when we're seeing these patients in clinic. So I think one of the things that's helped me is to kind of put this in a taxonomy of diagnosis. So one of the things we can refer to do this is called the Salerno criteria. So this is when a bunch of experts got together in a nice Italian city. There's always nice Italian cities where they do these guidelines together. And they looked at gluten-related disorders and the pathogenesis and how we can categorize them. And really, we're looking here at autoimmune conditions with gluten ataxia and gluten-related neurological conditions. And when we particularly talk about gluten ataxia, just like Ian was saying, it's an umbrella term for a group of neurological disorders affecting balance, coordination, and speech. And gluten ataxia specifically is one of the most common forms of sporadic idiopathic ataxia with no family history and no known previous cause. So that's kind of how we can look at the sort of how we could categorize it or give it a taxonomy. Now, in terms of the spectrum of neurological involvement, a little bit just like Ian was saying, this is some quite updated data. And I think the important thing about this slide is just really like Ian was saying, gluten ataxia or gluten involved neurology and sensitivity can exist in the absence of gut enteropathy, can exist in the absence of villus atrophy. And really, this is a table of a summary of Professor Hajivassalu's work, which is the consultant neurologist we all work with, over many, many years, over 25 years of data collection. And what you can see on the screen there is the number of percentage of patients with the different neurological disease and the percentage that present with gut neuropathy. And you can see a lot of them do not have the gut version, which is the important thing, I think, really to take home from this slide. Now, in terms of diagnosis, serological diagnosis, of course, Ian talked about the importance of native anti-gliadin antibodies, which we do have access to Sheffield. But the condition has moved on as well. Since 2019, we've had access to TTG6, tissue transglutaminase 6 antibodies. Again, to put it a little bit in context, this is the way I like to look about it without knowing all the ins and outs of the lab-based pathology of these antibodies. Is celiac disease would be TTG2, dermatitis herpetiformis would be TTG3, and then gluten ataxia or other neurological related gluten conditions would be TTG6. And TTG6 is promising, I think, in terms of the diagnosis. Certainly, Professor Hajivassalu will tell me it's a very sensitive antibody, and obviously Ian has given us a breakdown in his talk about how it can be applied. Unfortunately, it's only currently available in Sheffield, but hopefully as this becomes more globally aware, more people will get recognized with this condition and treated early. And I think one of the really important points of this talk is early diagnosis is vital for this cohort of patients. One of the main difference, obviously, we know in celiac disease is the gut can recover. In neurological conditions, it's often minimizing the deterioration that already occurred. And the earlier we recognize and diagnose these patients, the better it is, the better chance they have of improvement or minimizing deterioration. So again, Ian talked about spectroscopy, and I want to mention it again because I think it's so important, and it is an interesting tool that we have in our kit bag. Again, Ian was mentioning we have this chemical in the brain called N-acetyl-L-aspartamine, and that is a measure of your brain health, your cerebral health. So it varies depending on the function of your cerebrum. And then creatinine stays stable. And what you can see in this example on the top of your screen, that it's lower than post the patient going on to the gluten-free approach. You can see it's actually improved. And what we're looking for is that ratio between these two chemicals to improve. And really, when I've been seeing this patient, having access to these results has been really useful because we can combine different measures of outcome, the spectroscopy results, the blood results, and obviously our dietetic assessment. And I think we get a clearer picture of what's going on with the patients when we combine these outcomes together. I just wanted to give you a little bit of a view of like a case where it's progressed, just to give you a view of how it can affect a patient. So you can see that patient is obviously quite disabled and struggling with a balance and her walking, and it can really affect people's ability to, you know, deal with their daily activities, etc. And this is just an example, a little bit like Ian's talk of someone who has progressed. You can see there the cerebellum there, and then you know, a year or so later, there's severe deterioration. And really, what we want to recognize this and diagnose it quicker to minimize these risks. And I think this is one of the things about this patient cohort. It differs from celiac disease in terms of its effects and the ability for patients to recover once the damage has occurred. And it is, like I say, very common. In the white here, we have the biggest cause for ataxia, which is familial. And you can see the area, this black slice of the pie here is gluten ataxia. So it does seem to account for a significant diagnostic range within that cohort, that diagnosis. And we really need to be more aware of it. And as dietitians, we've certainly had referrals into our center from dietitians who've recognized maybe patients who present with celiac disease or maybe present with gait analysis. I know Professor Hajivassalu is quite keen for dietitians to do simple gait analysis in their clinics when they're seeing patients face to face. Of course, we have to be aware of our scope of practice, but to do a gait analysis is quite easy, and maybe we can talk about that in the Q&A. One of the things I think we do need to talk about is the gluten-free diet in related neurology, though. So I think we all think, or we all can think, that the gluten-free diet is codified, and we all know what it means. But I think we've got to bear in mind that really we don't really know what it is at an individual level. We've got these regulatory definitions. You know, historically, it was no more than 200 parts per million. In the UK and the States and other parts of the world, it's no more than 20 parts per million. In Argentina, it's no more for 10, and then in New Zealand and Australia, it's no more than 3. So you can already see there's differences of an opinion of what a gluten-free diet is from a regulatory perspective. And then we have these daily thresholds from research that have been done, maybe no more than 50 milligrams or no more than 10 milligrams a day. So I think even in the scientific research, there's a little bit of debate and confusion about what we really mean with a gluten-free diet. But when we're applying it neurologically, it's been extrapolated from celiac disease. There is no studies to determine what a gluten-free diet should specifically be in neurological gluten sensitivity. And I think we just need to bear that in mind and have maybe some epistemic humility about what the gluten-free diet really means at the individual level. Certainly, I always think a gluten-free diet indicates a supposed harmless level rather than complete absence, if you see what I mean. So I think we just need to bear that in mind, that yes, we have this concept of the gluten-free diet, but what it actually means, particularly at an individual level, there may be some variation between people. And that's to do with the definition, how people apply it, and then disease activity. And certainly in celiac disease, those things may not all join up in a way that we would like. And I think in neurological conditions, that could be the case as well. So moving quickly on, I think in terms of adherence, it's really important both in celiac disease, and I think this is something that we're trying to develop both with my colleagues Christine Costes and Dr. Yvonne Jeans as well in celiac disease. And I think we've got an opportunity in neurological gluten sensitivity to get in at the first floor. This is some work that Yvonne has developed looking at how we would describe or score or maybe rate a level of adherence. And I think as we see these patients with neurological gluten sensitivity more, if we could establish this at the national level, both from a clinical perspective, but also a research perspective, we could compare different centers and there would be less dietetic intervariation between dietitians. Ultimately, this is always going to be about clinical judgment, but I think we've got an opportunity, a window of opportunity with neurological gluten sensitivity to kind of codify and standardize our practice a little bit more. I'm sorry that's a busy slide, but maybe we can talk about it in the Q&A. Also, something we started to use locally with neurological gluten sensitivity patients is gluten immunogenic peptides. This was developed by our wonderful Spanish colleagues and friends. So I know this looks like a COVID test, but essentially it's a urine test. We get people to collect their urine over 3 days. It's important they do it over 3 days, maybe a weekday and 2 weekends. And to get people to collect it in the afternoon, not the morning, is better. And then we do this through the post. And then you can get, basically it's gluten in and gluten out, and you can get an indication of maybe if gluten's getting in. I think one thing I would say, there's a lot of research on this, and I can share the papers with you if you want. But we know from celiac disease that we have to be a little bit cautious. This one big study that was a seminal study, what it showed that patients that had, positive GIP, gluten immunogenic peptides, there was no statistical difference between patients with persistent villus atrophy or mucosal healing for those that tested positive. So I think we need to be a little bit careful when we're applying it in neurological conditions. Gluten immunogenic peptides may be more indicative of transitory transgressions rather than a complete lack of adherence. So we need to combine it with dietary assessment, with blood work, with the spectroscopy to get a better picture in my mind. I just want to give you a couple of clinical vignettes before we wrap up. I'm sorry, I may just go over a little bit over time. So most of the patients that we do see, what happens is they have a spectroscopy, a baseline spectroscopy, then a second one after they've been on the gluten-free diet for maybe 12 to 18 months, and it shows improvement in that ratio between creatinine and NAA. And then we see a reduction in both IgA and IgG tissue transglutaminase 6. However, that's not always the case. Sometimes what we can get is an improvement in spectroscopy, which is why I think it's so important, but the blood's never fully normalized in the way that we would like, despite someone appearing to adhere. So I think sometimes it's a little bit hard to unpick what's going on sometimes with these patients in terms of their adherence, but it's best to have a number of markers. Also, there's a very small number. We've had a case recently, maybe about 5% of the patients we see do have some form of refractory disease and will need immunosuppressive therapy. But I believe from speaking with Marios, Professor Hydrovassou, it's probably only about 5%. So in terms of nutritional considerations with this cohort, it is different from celiac disease. And that's not to say for patients with celiac disease, it's not challenging. So you will get people with food insecurity. You see that with celiac disease, but also in gluten-related neurological disorders. People with gluten-related neurological gluten sensitivity do not get any food on prescription, no matter where they live in the country. They can often have cognitive or memory issues that makes it hard for them to go shopping. They may have physical disabilities that makes it hard for them to shop and prepare food. They equally may have swallowing or dysphagia issues because of their deterioration. We may need to get speech and language involved. And they often have high rates. This is, in my clinical opinion, I've got no evidence for this yet, particularly high rates of food-related anxiety. And you can see why, just at a common sense level, why they would. So successful treatment with the gluten-free approach in neurological related conditions may require involvement of multiple support agencies, Nectarkin and wider support networks to do it properly. We're very lucky in Sheffield. We do have both myself and obviously Professor Hydrovassou, and we have some amazing ataxia specialist nurses that can sometimes help. And we will often self-advocate for the patients with GPs and primary care colleagues to try and get them foods on prescription where there is a really issue, but it can be quite a challenge for these various reasons. And I think with food hypervigilance, this cohort of patients really are at risk, in my opinion. It's a hypothesis I have. Again, this is seminal work from Dr. Rosie Slatherly, who's looked at this in celiac disease. One of the studies I'm hoping to do in the next 12 to 18 months is actually compare, by using the validated CFAB, feelings and behaviors in celiac disease, compare this to celiac disease to neurological gluten sensitivity patients to see if there is a difference. My feeling, no evidence yet, my feeling is then there could well be. And also, there's a lot of misinformation online. Unfortunately, I think we see this a lot in various practices of our work now, but we do need to understand what people are reading and what groups and things they're in. We've got to work with individuals so they can make informed, sensible choices and maybe not be overly restrictive. So I think just to wrap up, there are things we know about this cohort that we need to be careful with in terms of the physical effects and how we support them with the gluten-free diet. And there's things we don't know. What level of restriction? Are they more sensitive? Are they not? What about oat sensitivity, hypersensitivity, and the balance between serological markers and adherence, food-related quality of life? And what about the emerging non-dietary adjuncts like, latiglutenase, gluten enzymes, and the other treatments for celiac disease? Will they be available for people with neurological symptoms? So I'd just like to thank all my colleagues that I work with in Sheffield. And a very quick plug, we've got a symposium coming up on the 26th, Friday the 26th of May. If you're interested in more GI stuff, my lovely colleagues will be presenting, like my colleague Christine Costes. We've got a roundtable on IBS, loads of interesting stuff on pancreatitis and psychology. So if you haven't registered, please do. And I look forward to having a little bit of a Q&A. I'm sorry I ran over.
You can leave that slide up if you like, Nick, just to let people have a read of your agenda.
Okay.
Thank you very much, Nick. We've got a couple of questions that have come through, not many, which is probably a good thing given the time. Firstly, and I think this is for Nick, would people with neurological disorders like ALS benefit from gluten-free diet even without celiac disease?
Just could you say that for me again?
Would people with neurological disorders like ALS benefit from gluten-free diet even without celiac disease?
I think my opinion, my opinion is probably no. I don't think we've got the evidence for that. I think there's a lot of different situations where we're looking for, just because you've got an autoimmune disease, the idea that a gluten-free diet would work. I think we've got to be very careful and say these things haven't been explored. There's some marginal cases where we've had people maybe with gluten-related psychosis and things, but I don't think we've got the data to say formally that could really help that cohort. And we don't want people to restrict their diet unnecessarily. I completely understand people are looking for treatments, but the gluten-free diet is a significant undertaking that can affect your food and health-related quality of life and lead to nutritional deficiencies if not done properly. So I don't think we've got the evidence base to say in that cohort of patients.
Ian, anything to add?
I agree completely with what Nick said. I think all these different neurological conditions are all very individual and very unique. I am not aware of any research implicating gluten in ALS. So yeah, I think it has to be looked at very kind of case by case for these things. And yeah, I couldn't have put it better than Nick.
Thank you. Ian, there's a couple of questions about TG6 testing. So somebody has popped into the chat that they work in eating disorders and they test all new patients for CD, and it's expensive. So I wonder if it might be a barrier to accessing.
So currently, because it is a new test, there's all sorts of barriers, and I suspect cost might be part of that as well. So I've just finished running a study where I was doing the costing for all these different antibody tests, which included TG6, and I think gliadin tests were £8 a pop, tissue transglutaminase was £20 a pop, and TG6 was £50 a pop. That was what was quoted for me back in 2018, and I understand it's got better since then, now that within STH here, it is set up to be a test that can be ordered through just kind of regular clinical practice. So I think it's really going to, wind up hopefully getting better, the more the test is validated and sort of shown to be useful, and then hopefully adopted at different hospital trusts, then some of those costs can be sort of absorbed perhaps. I think, yeah.
So just further to that, what you were saying about requesting that test, can TG6 and gliadin antibodies be routinely requested? Or is it still being developed?
Within STH they can, yeah. So I think largely because of senior colleagues like Prof. Hajivaslu and David Sanders as well, they've really kind of advocated for these things to be available for testing in STH. So the labs that we have in Sheffield will receive this, through ICE and just kind of the regular kind of testing routes. I think theoretically any doctor within STH can request them. Usually it winds up being Dave or Marios or some kind of immediate colleagues who do. But yeah, it's as routine. It can be as routine as anything else here, but it's a local trust setup. It's quite bespoke.
Okay, thank you. And a question for both of you, and you may have already touched on this, Ian, when you said that, specific research is required rather than generous comments. What's the latest studies say about the gluten-free diet for people with autism?
It's a good question. I actually did a literature review on this a year or two ago. It's part of lockdown things to do. But yeah, no, it's an interesting area. The short answer, in my opinion, is that it's unresolved and there is not yet a clear-cut answer. I think theoretically, in terms of sort of mechanisms of action, there are reasons why we might expect some source of gluten sensitivity to be kind of overrepresented in people who have autism. There does seem to be a bit of extra overlap beyond chance between the two. But then when you actually go to, the biggest question of going, well, does the gluten-free diet help, kind of alleviate some, some of the more kind of troublesome issues that people with autism can suffer with? It's a real mixed bag. There was lots of randomized trials that kind of say no. There's a few that say yes. There's a couple in the middle. I think the biggest issue I saw when I was looking at the sum total of them is that there's really little replication of the same methods between them. So it's really difficult to compare one trial to another and to get kind of a holistic picture of it. So I do think it's something which warrants more research, but at the moment there really isn't a clear-cut answer in my opinion.
And there's a follow-on question to that. Has any research been done that you're aware of on gluten's impact on the brain in autism? And the reason they're asking that question is because they've noticed people with autism demonstrating signs of becoming intoxicated when consuming gluten-containing products and occasionally FODMAPs.
Yeah, I think the answers to that question is again kind of the same as sort of the general one. I think, yeah, there's I think the odd piece of research that does imply that there might be an interaction going on there, but it's just not been consistently replicated either. I think that when I was looking through it, the strongest sort of points of view on it did often seem to be anecdotal from parents of children with autism. But then, you know, in the proper controlled research, there were a few hints as well that there might be a signal there that needs to be looked at more. But I'm afraid it's just a grey area, I think, at the moment that needs more attention.
I think I would just add one thing. We've got to be very careful when we talk about FODMAPs, and gluten is a protein. FODMAPs are short chain non-absorbable carbohydrates. You know, the ingestion of a high FODMAP diet doesn't really or shouldn't really have an immune effect. Like, it shouldn't really cause extraintestinal symptoms. There is some data when we're talking about people with IBS that there may be a microbiome effect, that maybe have some, you know, immunological effects, but, you know, that's very localized to people with IBS. There's very different compounds within the diet in terms of gluten and FODMAPs, and I think these things sometimes can, understandably, you know, they can start to get merged when we have a discussion, but in terms of, you know, food hypersensitivity or negative effects from food, we want to be very careful to separate out gluten and FODMAPs as very different things, I think.
Thank you. Listen, we've got a few, as always happens when we start with the questions are now coming through, but we're almost out of time. So what I will ask, if you don't mind, Nick and Ian, if we send you those questions separately, would you mind just drafting very brief answers that we can share back with the link to the webinar? Please can you complete the survey, which the link to that is in the chat at the moment. We really appreciate your feedback. What I would just like to finish with is a huge thank you to both Nick and Ian for sharing your knowledge and expertise today. It's been really interesting. And I would like to also especially thank the BDA corporate member, Dr. Shah, who have made today's conversation possible. So thank you very much, everybody. And thank you to all of those who have attended. We hope you found it useful.
Thanks, everyone. Bye.
Thanks very much.